in this video, we're going to be discussing implicit differentiation. So, the basis of implicit differentiation is basically trying to find a solution to an implicit function. So not every function can be written explicitly. So explicit form is simply like something like y equals f of x, where there's two different variables on two different sides. But in an implicit function, there's two variables on the same side, and we can solve for y in an implicit function, but it can be a little difficult because we can get positive and negative roots, and we do not know which root we have to use in order to determine the solution. So this is where implicit differentiation comes into play, and so this is where implicit differentiation comes into play. So starting off, there are two ways to solve an implicit differentiation problem. There are two ways to solve it. However, we're gonna be just going straight into doing implicit differentiation. So we're gonna start with a problem. So the problem is find the derivative for xy is equal to 1. So one of the ways to do this problem is to actually rearrange this equation. So let me actually write this. So the way one of doing this problem is basically just solving for y. So solving for y, when you solve for y, all you have to do is just divide by x, and you get y equals 1 over x. And now you can just differentiate 1 over x and get negative 1 over x squared by the power rule. So this is this is the first way you could do this. However, we can do this another way as well, using implicit differentiation. So way 2 is implicit differentiation. So in this function, we're going to basically just leave the function in the form we have it in and just work with it in that form. However, let's just recall that from the first part of the solution, that if we could solve for y, then we will get y as a function of x. So over here, in the first way we solved this, we got y as a function of x. So in other words, basically, if you could solve for y, as we did in this case, we basically get something like this: y is equal to y x, and then we can rewrite the original equation to represent that. So xy is simply x y of x, and then equal to 1. So what I just did, let me repeat what I just did, because I feel like it got a little confusing once I got this part. So as you see in here, in the first solution, so in the first solution, well, we solve for y, and try to make y so it's a function of x. So you see, y is equal to 1 over x, so it's a function of x. So we're basically doing the same thing here. We're making y a function of x. So y equals y of x. So that of x, the of x represents that y is a function of x. So we're basically showing that in by rearranging and substituting for y into the original equation. So all we really did right now is just change this xy into this. We made this into a function of x. Now, the second step of implicit differentiation is to take the derivative of both sides. So I'm just going to label this step 1, step 2, differentiate both sides. So when we differentiate, we're going to be differentiate with both sides with respect to x. That's why we changed the function into a function of x. So we want to differentiate both sides with respect to x. So let's differentiate this function. So x y of x is equal to 1, right? Now when we differentiate both sides, and I'm going to use the d over dx notation in this case. So when we differentiate this, the right side of the function, we see that it's a constant. So the derivative of a constant is just 0. Now, on the left side, we're gonna have to do the product rule. This is one of those rules from your basic list of differentiation rules. So the product rule says that you multiply the derivative of u times v plus u times the derivative of v. So the two functions, u in this case is going to be x. U is equal to x, so u prime is equal to 1. V is equal to y of x, and v prime is equal to y. V prime is basically equal to, let's see, so it's going to be equal to y prime of x times x prime. And I'm multiplying this x prime because this is the chain rule. You see that there's two different functions. There's an outside function and an inside function. Y is the outside function, so outside function, and the x is the inside function. So you want one thing about implicit differentiation is that the chain rule is going to be involved in this in implicit differentiation as well. So I'm moving on. Now we can put everything together, where so u prime we know is 1, so it's going to be 1 times v. We know v is y of x, plus u we know is x, and v prime we know is y prime of x times so x prime the derivative of a variable is just 1. So derivative of a variable to the first power is just 1. So we just write 1 here. So this is what we get, and this is set equal to 0 because the derivative of 1 is 0. Now that we have this, we're left with, we can simplify this a little bit more, and we're left with 1. So we're left with y of x plus x, and then y prime of x times 1 is just y prime of x equal to 0. So now that we've gotten to this point, now we can actually rearrange this equation even more now. So now we can rearrange this equation a little bit more. So it looks like so we can actually find the derivative. So I'm gonna switch the y of x and y prime of x to just y plus x and y prime equals 0, just so we can just simplify it a little, and it looks a little pretty. So now that we've gotten to this point, the next step would be solve for y. So actually solve for y prime. Solve for y prime. Now when we solve for y prime, what we're gonna have to do is subtract y. So subtract y on both sides. You get xy prime equals negative y. Then we divide by x, so cancel out the x's. And we get y prime is equal to negative y over x. Now, it may look like we haven't found the solution yet, but we technically did find the solution, since we're in a form that all we have to really do is just substitute in for the function of y, and that's what we actually started with, right? That's what we started with. We solved it over here in the first way we found the solution. When we rearranged the original equation, so it's so we can solve for y, we got y equals 1 over x. So we have that component. So y is equal to 1 over x, and that's based off of this original equation after we rearranged it. So all we really have to do is just plug in for y. So it's going to be negative y is 1 over x, and then this is all over x. And when you simplify this, you get y prime is equal to negative 1 over x squared. So there's two ways to solve this problem. One, this way is a lot simpler. However, and this way is the longer way. But when you have bigger functions and a lot more complicated functions, then implicit differentiation is gonna be the way to go. So let's actually do another problem with implicit differentiation. So let's do find y prime of sine 3 minus 6x sine 3 minus 6x and sine y over x. So the first function we have to differentiate here is gonna be basically like a quick chain rule problem. So that chain rule problem is just this. So we're gonna be finding the derivative of sine 3 minus 6x, right? So when we take the derivative of this, the outside function we know is sine of x. Inside function is 3 minus 6x. So this is the outside function. This is the inside function right here. So let me make that into red. Now all we have to do is just differentiate. So we get, for the outside function, we get cosine. The derivative is equal to cosine of 3 minus 6x, right? We keep the inside function in there, and then we multiply this by the derivative of the inside function, and the derivative of 3 minus 6x is just negative 6. So the overall derivative of so I guess this is part A, and this is part B. So the derivative, so I'm going to label it right here too, part A. So the overall derivative, so y prime is for this first part A is negative 6 cosine 3 minus 6x. Now part B says that find the derivative of let's see, sine of y of x. So this is a more generalized way to actually solve this problem, and it's just asking you to give a general formula of solving for sine of y of x. So let's do that. Sine of y of x. So outside function here is sine of x. Inside function here is y of x. So y of x is a function is a function of x. So we have to remember to actually place the y prime, place a y prime when we're differentiating y of x. So we get, when we differentiate this, the derivative of sine of x is equal to cosine of y of x, right? We kept the parentheses the same, and then times the derivative of the inside function. So the derivative of the inside function is just y prime of x. So y prime of x, and this is our final derivative for part B. Now, so this was just the introduction to implicit differentiation. So moving on, there's also, so in these problems we were just applying our knowledge of the chain rule and understanding how to actually implicitly differentiate. However, there are more complicated problems, and this derivative shows up like all the time in implicit differentiation, so we need to just make sure we know how to do them. So the problem I'm talking about is basically where there's two different variables on the same side again. There's two different variables on the same time again, and it's set to a certain number or another variable, but we're gonna keep it a little simple. So x squared plus y squared is equal to 9, and what we want to do here is try to find y prime using implicit differentiation. So you want to find the derivative of this with by using implicit differentiation. We can solve this by solving for y, but we get a positive negative value, and once again, like, we don't know which is the right solution. Should we use both, or should we just use just one of the solutions? So the best way to approach this problem is using implicit differentiation. So we just follow the steps we listed for implicit differentiation here. So the first step was making y into a function of x. Second step is to differentiate both sides with respect to x. And then this third step is to solve for y prime. So let's do that. So we have y here. So the first step is going to be change y into y of x. So x squared plus y of x. So it's a function of x now. And now we can differentiate with respect to x. So second step, differentiate with respect to x. So we're going to differentiate both sides separately. So d of x squared plus y of x squared. and we're going to be differentiating that, and then the derivative of 9. So now we just solve for that. So the derivative of x squared is just 2x. Derivative of y to the x is, so it's going to be 2y of x, right? So this is going to be a chain rule problem right here. This itself is a chain rule problem. Outside function is x squared. Inside function is y of x. So when we normally differentiate x squared, we bring down the 2, subtract 1, and we get 2x to the power of 1. We just don't keep the 1 because x to the first is just x. So it's 2x, and x in this case is y of x. So 2 times y of x, and then we multiply by the derivative of the inside, and the derivative of the inside is just y prime of x. So that's the derivative of the left side of the equation. Now the derivative of 9 is just 0 because it's a constant, so it's 0. Now we can rewrite this a little, so we don't have all of these parentheses. So we can just write 2x plus 2y times y prime. So it looks a lot simpler, and we can now simply just solve for y prime, I mean. So when we solve for y prime, what we're going to want to do is subtract 2x on both sides. Divide by 2y. To cancel out. And our y prime is going to be negative 2x over 2y. But we can simplify this and say that y prime is just negative x over y because the 2's can cancel. And our final derivative using implicit differentiation for x squared plus y squared